Okay, afternoon, guys. If you recall this question, we were trying to figure it out, or I was trying to figure out, and what we didn't come up was with the right answer. Now, you can do the way of the marking key, which is to have two separate systems, one for the trolley and one for the counterweight. But in both cases, there will be tension, opposite to the direction of whatever we're looking at here. So here, that would be that. The trolley this way and friction this way, and then the tension would be that way. Okay? But a much simpler way is to just take both the trolley and the counterweight as one system, and as you can see, the direction of the tension is this way and the tension of the trolley is that way, and basically we're just going to ignore it because they're just going to cancel each other out. Even in the way this question is marked, they would cancel out as well, eventually. But we're just going to do the simple way of doing this, so let's get started in doing this, okay? Again, net force, is the sum of all forces. Net force also equals mass times acceleration. So we know this, okay? So what we're going to do is just identify the forces that are acting on the trolley and the counterweight, and we're just going to ignore tension, and you'll see why it doesn't really matter if we have tension or not. So we're going to have this one. This is going to be, the weight force is going to be M1 for the counter mass and gravity. And then the trolley, it's this way. It's the second mass, and gravity is going to affect it. So we have the weight force acting on the trolley, okay? And this way, we're told that there's a frictional force. So we've identified what forces are actually acting in the system, and we have their correct direction. Now this is going to translate into this direction for us, okay? And that is, well, that's going to be according to if we were to draw a vector diagram between the normal force here and the finding the reaction force, I should say, is going to be our normal force, okay? And that's just basically the components of this thing, right? That way and this way, so that would be M2G down the slope, I don't even know, what would I call that? I don't know what I would call that, but I know how we would get the equation or the equivalent of this component, right? So let's do that. So if I were to draw these two in, my M2G and my reaction force, okay, tip to tail, and then I draw this one in for the net force for those two, well, the angle that we have here for the slope 11 goes opposite that component. So we'll put it here. I would say it's the net force between these two, but you'll see that it's just a sine ratio of M2G. So it's just going to be this M2G sine 11 degrees. And we get that because it's opposite. These two are perpendicular. As you can see, that force is parallel to the slope, and reaction force is perpendicular to the slope. So those two are 90 degrees to each other. And that's how we get this value here. So then we know it's M2 times gravity times sine of 11 degrees. Okay? So that's it. Now we've used these up. We don't have to worry about these anymore because we've just found the component for weight force here, the vertical weight force of the trolley here. So now we only have this force, which is given to us. We can figure that out. We'll put it into our equation because we know mass, we know gravity, we know all that. And then we know the mass of that one as well, okay? And so let's take a look. We can see that the frictional force and this force of gravity acting on the trolley is both in the same direction, which is opposite along this rope to the counterweight. So if we look at the net force of this, right, it's going to be, we know that it's going to be all those things, but in terms of net force, we want to know, we want to show that the trolley accelerates up the hill at 1 meter per second square. So let's do this. We'll rearrange this so that we get A equals the net force, and this mass is going to be the mass of both the trolley and the counterweight, because it's both the trolley and the counterweight that are accelerating, okay? So just gonna put a T here for the total weight. Okay, so let's take a look at our net force and see what happens. So we have this one, M1 times G, and accordingly that is 4 bags that are 15 kilograms each. So we know that's gonna be 60, okay? So I'll write here this first just so we get everything in. And then it's going to be minus these two, the frictional force and our weight force component acting on the trolley. Okay, and all that's divided by the total masses, so mass 1 and mass 2. Okay, so again, it's just net force equals mass times acceleration, rearranging this formula so that we can solve for acceleration due to all the forces that we add together. And in this case, it's the force of the counterweight minus the friction force and minus the force acting on the trolley in the direction of the slope. Okay? Very easy, that part. Now this one you might not understand, but you should, because as a whole, we are accelerating both the trolley and the counterweight, right? Because they're connected by that rope. Okay, so we're there so far. Now, we'll just plug it in. M1 is 60 kilograms. 60 kilograms there times 9.8. I'll just put the X there. Minus F, friction force FF, which is 60 newtons already, minus this part here, which is the second mass, which is the trolley. And if we identify, we should identify it already here. Okay, M1 is 4 times 15 equals 60. And then M2 would be equals 163. Okay, so good to write that out so you know everything is. So we're going to just follow this that we came up with, 9.8, and that's going to be sine 11 degrees. Okay, and then that's all divided by the first mass, which is 60, plus the second mass, which is 168. Okay, and you'll find that comes out to about 1. So let's double check, put it in our calculator. Okay, so all that, you can just see it's going to be 1 fraction. So I'll use my fraction key, plug this in, 60 times 9.8 minus 60 minus 163 times 9.8 times sine 11, and we'll just close this off in case it gets funky here. Go down, put these two together, 60 plus 163 Press enter, and you can see our acceleration is 1. Okay. So at this point, you can pause it and just look at all the numbers if you wish. Okay, double check everything. But there it goes. Like I said, this is much simpler. We can ignore the tension in the rope for both individual components because eventually they would cancel out anyway. See, if the tension's this way, the tension this way, remember, away from this mass, away from that mass, and you can see they're heading in the opposite direction. So it is possible just to ignore and cancel them out right away. And then we have a less complicated equation. Okay?